Let's do it. Anybody know what a perfect square is? I'll refresh your memory. A perfect square is the product of a number and itself. All right. For instance, 100 is a perfect square because what times what would give you 100? 10 times 10. A number in itself gives us 100. So 100 is a perfect square. Give me another perfect square that you know of. That a number times itself will give you this number. I ain't moving till you tell. Perfect square. Give me a perfect square. Give me a number or a product that is a number and itself when they multiply. 6 who?
16.
Oh, I like that. 16 is a perfect square because what time what is 16? 4 times 4, a number and itself. Give me another perfect square.
2.
Well, 2 is 1 times 2, but what times what, that's the same thing, will give us this number. Yeah, there you go. Okay, I was trying to, 4, that's right. 4 is 2 times 2. These are perfect squares. So what I'm going to do now, I'm going to list some perfect squares for you, minus the 3 that we have, so you will have a list of them, okay?
What about 9?
9, exactly. Yeah, let's just list them. 1 is a perfect square because what time what gives you 1 is the same. 1 times what? 1. Yeah, that's perfect square. All right, we already got 4. 9, like you said, is a perfect square because what time what is 9? 3 times what?
3.
Yeah, 2 things. 3. So a number times itself. All right, the product of a number in itself is a perfect square. All right. So another one is, we already got 16 up here. 25 is a perfect square because what? 5 times 5. 36, I saw somebody was about to say it earlier because it's what? 6 times 6. All right. 49 is a perfect square because what? Yeah, it's a product of 7 times 7, number in itself. 64 is a perfect square because, there you go, 8 times 8. Let's do, we already know, nope. 81 is a perfect square because what? 9 times 9. We already have 100. We're going to do a couple more. 121 is a perfect square because that is 11 times itself, which is also 11. 144 is a perfect square because it's 12 times 12. 169 is a perfect square because that is 13 times 13. And we'll do one more. 196 is a perfect square because, guess, 14 times 14. All right, let's do 15. 225 is a perfect square because we have 15 times 15. All right. Perfect squares are the product of a number and itself. A lot of these we knew already. You just didn't remember what they were called. Now, the way perfect squares, the next note we need to deal with that goes with this is radicals or radical expressions. All right, radical expressions. A radical expression is when you have a radicand. That's that symbol right here. So this symbol is called, the radical. Put an L at the end. Radical is a symbol. The stuff, you can't see it? That's radical. That's a radical symbol. The stuff underneath here is called the radicand. So the stuff underneath, inside, there we go. That's called the radical. can, radical is the symbol, inside the stuff is radican. One of the most important things we can learn about this part is that blank space right here in the middle. Anybody know what that space is called? That's your index. Your index is that blank, that little space between in that radical. Alright? Now, a blank index means how much? Anybody know? A blank index means there's a 2 in there. Alright? So we have the radical as the symbol, the radicand is stuff underneath here, underneath the umbrella or the radical, and the index is that space in that little dip right there. Now, the way it goes is, whatever your radicand is, when you factor, if you find 2 of the factors that are the same, a number in itself, that number comes out. For instance, when we did the square root of 25, what's the index? 2. Why is the index 2?
Is it blank?
It's blank. Ain't nothing in there, right?
Oh.
So when it's empty right there, that means square root, that's why it's called a square root. There's a 2 in there. When it's blank, it's an automatic 2 right there. So you can have a cube root, you can have a 4th, 5th, all that. So when it's blank, there's an understood 2. What that 2 means, I need 2 of the same factors in order to come outside of this umbrella. I need 2 of the same factors. So when we factor 25, we say 25 is 5 times 5. We have what? 2 of the same factors, right? 2 of the same numbers, right? So when you have 2 of something, that number comes out of the radical. That's why the square root of 25 is 5. Let's try it again. The square root of, let's say, 49. What time was 49? 7 times 7, correct? What's the index? 2. Do you have 2 or something?
Yeah.
So a 7 comes out, and that's how the square root is 49. It's 7. One more time. The square root of 8. Now, let's factor 8. What time what is 8? 4 times 2. Now, we're not done because 4 is something times something. 4 is what times what?
2 times 3.
Now, do you see 2 of the same number in these factors here? So, remember, the index is like a code. It said if you find this number, take it out. So we're going to circle. We need 2 of something. We found 2 of these, and what's left over?
2.
So your answer is 2, because I found 2 of these. A 2 comes out, but what's left over? A 2. Let's do it again. Let's do it again. Square root of, let's say, 27. All right. What's our index again? 2. I need 2 of something, right? What time what is 27? 9 times 3. Now 3, see, we don't use ones. We don't use units to break anything down. 1 time anything, that's forever, so we don't use that. But 9 is something times something. What? 3 times 3. Remember, your index is your code. It's telling you, if you find 2 of something, take it out. Do we have 2 of anything?
3.
So we got 2 3s. So a 3 will come out, but what? A 3 is left over. So the square root of 27 is 3 square root 3. Let's keep going. All right. Let's do the square root of 54. All right. Now, any even number, 2 times something to give it to us. Any even number. But if you know, you know. All right. So what time would it give us 54? We can use 2. 2 times what? 27. Right? Right? I guess you're going to take my word for it. 2 times 27, 54. 27 is what times what again? 9 times 3. But 9 is what? 3 times 3, right?
Mm-hmm.
All right. Do you have 2 of anything?
Yes.
2 what?
3.
So we're going to take out 2 3s. So we get 3 came out, but what's left in? And 3 and 2, right? 3 and 2, because we can't use the 9 because we broke it down. So 3 and 2 is what's left in. What's 3 times 2? 6. So remember this: when you are solving radical expressions or simplifying radical expressions, when whatever you find 2 of comes out. Whatever's left is multiplied back. All right. So this is an activity on we're gonna get into real detail about this stuff in our next unit. But I have to show you this before we do this next section. There are going to be times when you have the square root of, let's say, negative 49. All right, this is impossible because a perfect square means I got 2 of the same things to give me this radicand. 2 of the same things. We know 7 times 7 gives us 49, but what time would it give us a negative 49 that's exactly the same? I'll wait. Okay. What's negative 7 times negative 7? Positive 49.
Negative 5.
But remember, a perfect square means I need the exact same thing twice to get this under here. You can't do it. Because a negative times negative is always going to be a what? Positive. So in that case, what you do then is you split this. You split this to negative 1 times whatever your number is. I don't care what that number is. You split it to negative 1 times whatever it is. All right? Every time. The reason being because the square root of negative 1 has a meaning. Just for right now, understand when you see a negative square root of 1, square root of negative 1, put a I right there. All right? It's imaginary. Anytime you see square root of negative 1, put an I. And then we know 49 is 7 times 7, which is perfect root. The square root of 49 is just what? 7, right? So that is 7i. Let's try it again. If I said, what is the square root of negative 25? How you break it up?
Blank index means we have to find 2 or something. And there's no way a number times itself can give you a negative.
Oh, how you break it up? You got to take that negative 1 out. Negative 1, square root of negative 1 times the square root of just what?
25.
And keep the 25 in its own radical. Now, the square root of negative 1 is I. And 25 is 5 times 5. So that's 2, blank index, 2 or something. So that number comes out. So the 5 comes out. The square root of 25 is just 5. Put those together. Now, anytime you multiply a number and a variable, you don't say x2 or y3. The number comes first, coefficient, and then imaginary number. So the square root of negative 25 is 5i.